Psychological problems can certainly result from damage to the structure of the brain. Often, however, the cause of such problems is chemical. Too much or too little of a particular neurotransmitter or another chemical that gets in the way of neurotransmitter function can lead to a number of disorders, including depression and drug addiction. Take dopamine, for example. Normally, this neurotransmitter is found in many parts of the brain and is involved in such things as movement, regulation of heart rate, and the release of certain hormones. Dopamine also plays a role in motivation. Scientists have discovered that it provides the sort of desire you feel in anticipation of something good. So what happens when the brain has too little dopamine, or something interferes with its normal action? Dopamine is produced in several areas of the brain, including these tiny areas deep in the brain here, the substantia nigra and the ventral tegmental area. All neurotransmitters are transmitted along pathways, and dopamine is no different. The neurons along the dopamine pathway have long axons that extend the entire length of the pathway. In this way, dopamine produced in one area of the brain is able to influence brain function in another region, such as the frontal cortex and the striatum. In general, dopamine is involved in the control of movement and the sensation of pleasure. However, depending on where in the nervous system it is active, its role can vary from delivering excitatory signals to delivering inhibitory signals. Just as location can influence the action of dopamine, so too can the presence of various drugs. Cocaine, for example, inhibits the reuptake of dopamine by the neuron's terminal buttons. This increases the availability of dopamine in the synapse and increases dopamine's effect on other neurons. The immediate effect on an individual under the influence of cocaine is a feeling of euphoria, but it doesn't last long, and this can drive the person to seek out more of the drug. Recurrent stimulation of the dopamine receptors ultimately results in a reduction or pruning of these receptors, and this reduces the drug's effect. This could increase demand for the drug, which in turn can change the brain's chemistry even further. There are many more examples that illustrate the importance of having the proper amount of a particular neurotransmitter. For instance, too much dopamine has been linked to symptoms of schizophrenia, while too little dopamine may be involved in Parkinson's disease. This research shows just how critical the balance is between having enough of a particular neurotransmitter but not having too much. It demonstrates the critical role that chemicals play in brain function and psychology, and it shows how drugs that alter brain chemistry have played such an important and sometimes devastating role in many societies, and why other such drugs have become so important to the mental health care field.